Welcome to Tech with Kaushik. This is set 14 of our DOP-C02 AWS Certified DevOps Engineer Professional Practice Question Series. Choose your answer before the timer ends. Then review the correct answer, detailed explanation, and exam tip. Keep track of your score and see how exam ready you are. Each practice set is completely standalone, so you can start here without watching any of the other sets first. Playlist link in the description. Let us begin set 14. Question number 240. Let's go. This question checks your understanding of STS cross-account role. Scenario. An enterprise uses AWS organizations to manage its cloud footprint. The platform team maintains a custom AWS Lambda function in the management account that automates the provisioning of new AWS accounts by invoking the organization's Create Account API. To comply with a new architectural standard isolating operational tooling, the team must migrate this Lambda function to a dedicated automation member account. The migrated Lambda function must retain the ability to programmatically create new accounts within the organization. Which configuration enables the Lambda function in the new account to successfully create AWS accounts? Options. Option A. In the management account, create an IAM role with the organizations. Create account permission and configure its trust policy to allow the Lambda execution role from the automation account to assume it. Update the Lambda function code to perform an STS assume role call prior to creating accounts. Option B. In the management account, enable delegated administration for AWS organizations and assign the automation account as the delegated administrator. Attach the organizations. Create account permission directly to the Lambda execution role. Option C. In the management account, create an IAM role with the organizations. Create account permission and configure its trust policy to allow the Lambda to Amazon AWS.com service principal. Update the Lambda execution role in the automation account to directly assume this role. Option D. In the management account, enable AWS Control Tower and configure delegated administration for the automation account. Update the Lambda function to utilize the Control Tower Create Managed Account API instead of the organization's API. Go with option A. In the management account, create an IAM role with the organizations. Create account permission and configure its trust policy to allow the Lambda execution role from the automation account to assume it. Update the Lambda function code to perform an STS assume role call prior to creating accounts. This is the best choice because the organization's Create Account API action is highly privileged and can strictly only be executed within the context of the AWS organization's management account. Because the Lambda function is moving to a member account, it must temporarily elevate its privileges back into the management account. This is accomplished by establishing a cross-account IAM trust. The Lambda's execution role uses the AWS STS assume role API to assume a role residing in the management account, executing the creation command under that role's context. Now let's rule out the other options. B. AWS organizations supports delegated administration for certain integrated AWS services, like Security Hub or Guard Duty, but it does not support delegating core organizational management actions, such as organizations, create account, to member accounts. C. A trust policy that directly allows the Lambda to Amazon AWS.com service principal means any Lambda function in the management account could assume it. However, the Lambda is running in the automation account. It is the Lambda's execution role, not the generic service principal, that must be trusted across the account boundary. D. AWS Control Tower Account Factory can provision accounts, but migrating the Lambda to use the Control Tower API fundamentally changes the provisioning architecture requested by the scenario, and Control Tower provisioning is heavier than simple organizations account creation. Keep this point in mind for the exam. AWS organizations' core actions, like create account or modifying SCPs, cannot be delegated. A resource in a member account must use STS assume role to assume an IAM role in the management account to perform these actions. Here comes question number 241. Here's the scenario. A DevOps team is setting up an Amazon ECS Blue/Green deployment pipeline for a containerized application using AWS CloudFormation and the AWS Code Deploy Blue/Green integration. To minimize deployment risk, engineering leadership mandates that production traffic shift to the new task set in equal 20% increments with 1 minute between increments until all traffic has migrated. Which CloudFormation template configuration should the DevOps engineer implement to satisfy these requirements? The choices are: Option A. Add an app-spec file that references the code deploy default.ecs linear 10% every 1 minutes deployment configuration. Option B. Include the AWS code deploy blue-green transform and an AWS code deploy blue-green hook with traffic routing config set to time-based linear, step percentage set to 20, and bake time mints set to 1. Option C. Include the AWS code deploy blue-green transform and an AWS code deploy blue-green hook with traffic routing config set to time-based canary, step percentage set to 20, and bake time mints set to 1. Option D. Include the AWS code deploy blue-green transform and configure the hook by naming a code deploy default ecs linear 10% every 1 minute's deployment configuration instead of specifying traffic routing config. The answer here is option B. Include the AWS code deploy blue-green transform and an AWS code deploy blue-green hook with traffic routing config set to time-based linear, step percentage set to 20, and bake time mints set to 1. The main reason is for CloudFormation managed Amazon ECS blue/green deployments. The AWS code deploy blue-green hook defines traffic shifting through traffic routing config. Time-based linear performs equal traffic increments. Step percentage specifies the percentage moved at each step, and bake time mints specifies the interval between steps. A 20% step with a 1-minute bake time exactly matches the requirement and satisfies the CloudFormation minimum step percentage constraint. The other choices do not work because A. An app spec file does not define the CloudFormation blue/green traffic routing policy, and the name code deploy deployment configuration is not how the CloudFormation hook expresses linear routing. C. Time-based canary uses a 2-increment canary pattern rather than repeated equal linear increments. D. The CloudFormation blue/green hook requires traffic routing config properties. It does not accept the code deploy deployment configuration name as a substitute for time-based linear settings. For CloudFormation ECS blue/green deployments, distinguish code deploy deployment configuration names from the CloudFormation hook syntax. Use traffic routing config with time-based linear or time-based canary parameters. Next up is question number 242. Here's what is happening. An enterprise application exposes an API that returns real-time workload performance metrics. The platform engineering team needs to audit, analyze, and visualize these metrics across the entire fleet to detect performance degradation and anomalies at scale. Which combination of architectural steps will accomplish these requirements? Choose 3. Choose every option that satisfies the requirement. Review the options. Choice A. Configure an Amazon EventBridge schedule rule to invoke an AWS Lambda function that queries the API for workload metrics and stores the payload in an Amazon S3 bucket. Choice B. Configure an Amazon EventBridge schedule rule to invoke an AWS Lambda function that queries the API for workload metrics and writes the records to an Amazon DynamoDB table with DynamoDB streams enabled. Choice C. Create an AWS glue crawler to catalog the workload metric data stored in the Amazon S3 bucket and create tables and views in Amazon Athena for querying. Choice D. Connect an AWS glue crawler directly to the DynamoDB stream to catalog the workload metric data for Amazon Athena. Choice E. Create Amazon QuickSight datasets from the Amazon Athena views and build an Amazon QuickSight analysis dashboard to visualize the performance metrics. Choice F. Create an Amazon CloudWatch dashboard with custom widgets that invoke AWS Lambda functions to query aggregated metrics directly from Athena views. The answers that work here are option A. Configure an Amazon EventBridge schedule rule to invoke an AWS Lambda function that queries the API for workload metrics and stores the payload in an Amazon S3 bucket. Option C. Create an AWS glue crawler to catalog the workload metric data stored in the Amazon S3 bucket and create tables and views in Amazon Athena for querying. And option E. Create Amazon QuickSight datasets from the Amazon Athena views and build an Amazon QuickSight analysis dashboard to visualize the performance metrics. This works because ingesting API metric payloads into Amazon S3 through scheduled EventBridge and Lambda invocations provides durable storage. An AWS glue crawler can catalog the S3 data for Athena and Amazon QuickSight can use Athena datasets and analyses to visualize the resulting fleet-wide metrics. B. DynamoDB can store the records, but DynamoDB streams are a change data capture stream and do not provide the direct glue crawler to Athena path described by the correct architecture. D. AWS glue crawlers do not crawl DynamoDB streams directly as an Athena catalog source. F. CloudWatch custom widgets that invoke Lambda to query Athena add custom integration overhead compared with the native Athena to Amazon QuickSight Analytics path. Exam tip. For serverless archival analytics, a common pattern is S3 for durable data, Glue Data Catalog for schema discovery, Athena for SQL queries, and Amazon QuickSight for visualization. Now for question number 243. A machine learning platform runs containerized workloads on an Amazon EKS cluster whose EC2 worker nodes are registered as AWS Systems Manager managed nodes. Large container images are causing long pod cold starts. The engineer has tagged the worker nodes that should receive image prefetching, and an Amazon Event Bridge rule detects new image pushes in Amazon ECR. A Systems Manager command document contains the image pull logic. What must the DevOps engineer do next to complete the event-driven prefetching configuration? Option A. Create an Event Bridge target role and configure Systems Manager run command to execute the prefetch document against EKS control plane nodes. Option B. Configure Event Bridge run command parameters to target worker nodes by EC2 instance size and execute the prefetch document. Option C. Create an IAM role that allows Event Bridge to call Systems Manager send command. Configure Systems Manager run command as the rule target and use run command parameters with worker node tags to execute the prefetch document on the tagged EKS worker nodes. Option D. Create a Systems Manager State Manager association for the worker nodes and rely on the Event Bridge event to refresh the association without configuring a run command target. The best choice is option C. Create an IAM role that allows Event Bridge to call Systems Manager send command. Configure Systems Manager run command as the rule target and use run command parameters with worker node tags to execute the prefetch document on the tagged EKS worker nodes. Event Bridge can use Systems Manager run command as a target. Event Bridge calls send command on behalf of the rule, and run command parameters can target managed EC2 instances by tags. Targeting the tagged EKS worker nodes runs the image prefetch document exactly where kubelet later needs the image. The remaining options can be eliminated because A. The managed EKS control plane is not the customer-managed worker fleet that runs application pods and pulls their images. B. Event Bridge run command targets support instance IDs or tags, not EC2 instance size as a target selector. D. A state manager association is a desired state mechanism, but the described event-driven flow requires the Event Bridge rule to invoke the command target when an EC or push event occurs. Here's a useful exam tip. For Event Bridge to Systems Manager automation on EC2-backed fleets, run command can be a rule target and can select managed nodes with tag-based run command parameters. Next, question number 244. The focus now shifts to security and compliance. An application stores sensitive customer data containing personally identifiable information, PII, in an Amazon S3 bucket encrypted with AWS KMS customer managed keys deployed via AWS CloudFormation. A DevOps engineer must establish a weekly synchronization process to copy production data into a development environment S3 bucket located in a separate AWS account. Organizational compliance policies strictly prohibit moving unanonymized PII out of production, and each account must utilize independent KMS keys for encryption. Which combination of steps should the DevOps engineer take to meet these requirements? Choose 2. Select all answers that apply. Option A. Activate Amazon May-C on the production S3 bucket. Configure an AWS step function state machine to run a discovery job and redact all PI prior to copying objects to the development S3 bucket, and grant the state machine tasks appropriate KMS decrypt and encrypt permissions. Option B. Configure native S3 cross-region replication between production and development buckets. Activate May-C on the development bucket and implement step functions to redact PI upon ingestion with development KMS permissions. Option C. Set up an S3 batch operations copy job between production and development buckets. Configure an AWS Lambda function with S3 object Lambda to redact PI on retrieval and grant the Lambda role encryption permissions. Option D. create the development environment using the CloudFormation template in the target account, and schedule an Amazon Event Bridge rule to trigger the PI redaction step function state machine on a weekly cadence. E. Deploy the development stack using CloudFormation and configure a cron job on a standalone EC2 instance to execute an S3 batch operations job weekly without data transformation. You should choose option A. Activate Amazon May-C on the production S3 bucket, configure an AWS step function state machine to run a discovery job and redact all PI prior to copying objects to the development S3 bucket, and grant the state machine tasks appropriate KMS decrypt and encrypt permissions, and option D. Create the development environment using the CloudFormation template in the target account and schedule an Amazon Event Bridge rule to trigger the PI redaction step function state machine on a weekly cadence. Here's why. Amazon May-C identifies sensitive PI data in S3. A step function state machine orchestrates the discovery, redaction, and secure cross-account copy operations while utilizing proper KMS decrypt permissions in production and encrypt permissions in development. Event Bridge provides reliable weekly scheduling for the state machine. Here's why the alternatives are not suitable. B. Native S3 replication replicates data directly without built-in PI redaction, violating the compliance requirement against moving unanonymized PI. C. S3 object Lambda redacts data on GET requests rather than transforming data during weekly bulk synchronization copies between production and development. E. Standalone EC2 cron jobs lack native serverless state orchestration and security governance compared to step functions. A helpful shortcut is this. When compliance requires anonymizing PI before cross-account data transfer, use automated orchestration, step functions, combined with discovery services, May-C, rather than raw S3 replication. Question number 245. Consider this situation. A web application's infrastructure is defined using AWS CloudFormation. The database engineering team manages core database infrastructure in a dedicated CloudFormation template, while software developers manage application resources in a separate template. Both teams enforce strict, independent review and lifecycle governance workflows, including resource-level change set inspections, and the software team deploys updates via their CI/CD pipeline. Which solution allows the software development stack to securely consume database resources while preserving independent lifecycle management? Here are the options. Choice A. Create stack outputs with export values in the database CloudFormation template and import those references into the application CloudFormation template using intrinsic functions. Choice B. Implement a CloudFormation nested stack architecture to combine cross-stack resource references and parameter sharing into a single unified deployment. Choice C. Deploy a CloudFormation stack set across the organization to automatically propagate cross-stack resource references and shared parameters. Choice D. Configure dynamic input parameters in the application CloudFormation template and manually pass database resource identifiers at deployment time. The right response is option A. Create stack outputs with export values in the database CloudFormation template and import those references into the application CloudFormation template using intrinsic functions. Let's look at the reasoning. CloudFormation stack exports and the FN import value intrinsic function allow independent stacks, such as database and application stacks maintained by separate teams, to securely share resource references while preserving independent review and lifecycle management processes. Let's quickly check the incorrect choices. B. Nested stacks time multiple templates into a single deployment lifecycle, violating the requirement for independent team review and lifecycle management. C. Stack sets are designed for multi-account or multi-region deployment of identical templates, not cross-stack referencing between distinct functional stacks in the same environment. D. Manually passing parameters introduces operational overhead and human error, whereas stack exports automate cross-stack references securely. The main takeaway is use CloudFormation stack exports and imports to share resources between independently managed stacks without tightly coupling their deployment lifecycles. Question number 246. A development organization mandates that all infrastructure changes must be deployed strictly through AWS CloudFormation. Engineers must not be able to modify application resources directly. Developers currently use an IAM role with administrator access. Management creates a CloudFormation deployment service role that will have least privilege permissions to manage the required Lambda, DynamoDB, and elastic load balancing resources, and only CloudFormation must be able to assume this role. Which combination of steps will enforce this security control? Choose 3. Identify all valid responses. Choices. Option A. Remove administrator access from the developer role and grant only the CloudFormation stack and change set permissions required for deployments, without granting direct write permissions to Lambda, DynamoDB, or elastic load balancing. Option B. Update the trust policy of the CloudFormation deployment role to allow developers to assume the role directly for interactive deployments. Option C. Grant the developer role IAM. Pass role only for the CloudFormation deployment role with an IAM. Pass to service condition of CloudFormation.AmazonAWS.com. Option D. Configure the CloudFormation deployment role trust policy with the CloudFormation.AmazonAWS.com service principal and the STS. Assume role action and attach only the target service permissions CloudFormation needs. E. Keep administrator access on the developer role, but require MFA before CloudFormation stack operations. F. Attach CloudFormation * permissions to the CloudFormation deployment service role instead of granting it the Lambda, DynamoDB, and elastic load balancing actions required to manage stack resources. The correct answers are Option A. Remove administrator access from the developer role and grant only the CloudFormation stack and change set permissions required for deployments, without granting direct write permissions to Lambda, DynamoDB, or elastic load balancing. Option C. Grant the developer role IAM. Pass role only for the CloudFormation deployment role with an IAM. Pass to service condition of CloudFormation.AmazonAWS.com. And Option D. Configure the CloudFormation deployment role trust policy with the CloudFormation.AmazonAWS.com service principal and the STS. Assume role action and attach only the target service permissions CloudFormation needs. This is the best choice because developers need CloudFormation stack permissions, but must lose direct administrative write access to managed resources. They also need narrowly scoped IAM. Pass role permission so that CloudFormation can use the designated service role. The service role itself must trust the CloudFormation.AmazonAWS.com service principal through STS. Assume role and contain the least privileged target service permissions needed to operate the stack. Now let's rule out the other options. B. Direct developer assumption of the deployment role would permit interactive resource changes and defeat the control that only CloudFormation may use the role. E. MFA improves authentication assurance, but does not remove the developer role's direct administrative permissions. F. A CloudFormation service role needs permissions for the resources CloudFormation manages. CloudFormation * on the service role does not substitute for the required Lambda, DynamoDB, and load balancing permissions. Keep this point in mind for the exam. CloudFormation service role governance has 3 distinct permission surfaces: caller CloudFormation permissions, caller IAM, pass role permission, and a service role that trusts CloudFormation, AmazonAWS.com, and holds least privilege resource permissions. Question number 247. A DevOps engineer is utilizing AWS Systems Manager documents to bootstrap developer laptops. The bootstrap configuration scripts and assets are hosted in a GitHub repository. The engineer has already created a Systems Manager activation, installed the SSM agent on all target machines using the registration code, and verified activation IDs. What configuration step must the DevOps engineer take next within the Systems Manager document? Here are the options. Option A. Configure the SSM document to execute an AWS run shell script command that copies files from GitHub to Amazon S3, followed by the AWS download content plugin with an S3 source type. Option B. Configure the SSM document to utilize the AWS configure package plugin specifying an install action pointing directly to the Git remote URL. Option C. Configure the SSM document to use the AWS download content plugin specifying a source type of GitHub along with source info parameters containing repository details. Option D. Configure the SSM document to run the AWS software inventory plugin to pull and execute runtime scripts from the remote Git repository. In this case, choose Option C. Configure the SSM document to use the AWS download content plugin specifying a source type of GitHub along with source info parameters containing repository details. The main reason is AWS Systems Manager provides built-in plugins such as AWS download content, that natively support pulling content from external sources like GitHub when configured with the appropriate source type and source info parameters. The other choices do not work because A. Copying files to S3 as an intermediate step introduces unnecessary operational overhead when plugins support direct downloading. B. The AWS Configure Package plugin is designed for installing software packages from Systems Manager Distributor, not pulling raw Git repositories. D. The AWS Software Inventory plugin collects installed application metadata rather than bootstrapping or downloading code repositories. When downloading external repository content in Systems Manager documents, use the AWS Download Content plugin with GitHub source types rather than custom shell scripting. Now for question number 248. This question takes us into CI/CD pipelines. Consider this situation. A developer is prototyping an AWS Lambda function using the AWS Serverless Application Model, AWS SAM. The SAM template defines an AWS Serverless function resource with its code URI property pointing to an Amazon S3 archive location. After successfully deploying the initial version by uploading a package.zip file to S3 and running SAM deploy, the developer updates the function code, uploads the new zip archive to the same S3 location, and reruns SAM deploy. The deployment fails and returns an error indicating that there are no changes to deploy. Which solutions will successfully deploy the updated function code? Choose 2. More than one answer may be correct. Review the options. Choice A. Execute the AWS CloudFormation update stack command directly instead of using SAM deploy. Choice B. Execute the AWS CloudFormation update stack instances command to force deployment synchronization across stacks. Choice C. Update the code URI property in the template to reference the local application code directory and execute the SAM deploy command. Choice D. Update the code URI property to reference the local code directory and manually execute AWS CloudFormation create change set followed by execute change set. Choice E. Update the code URI property in the SAM template to reference the local application source code folder and run AWS CloudFormation package followed by AWS CloudFormation deploy. The required selections are option C. Update the code URI property in the template to reference the local application code directory and execute the SAM deploy command, and option E. Update the code URI property in the SAM template to reference the local application source code folder and run AWS CloudFormation package followed by AWS CloudFormation deploy. This works because when AWS SAM points directly to an S3 zip location without modifying local code references or build packaging commands, SAM computes a hash of the S3 reference and detects no template changes. Referencing the local code folder allows SAM deploy or package and deploy to detect local changes, package the code, upload a new archive version, and trigger a successful stack update. A. Running raw CloudFormation update stack without packaging updated code artifacts does not upload new code changes or resolve local source references. B. Update stack instances applies to stack set stack instances, not single stack SAM updates. D. Creating and executing change sets manually without packaging updated local source code still leaves the template pointing to unchanged static S3 objects. Exam tip. When using AWS SAM, reference local source directories in code URI to allow SAM to automatically handle packaging, hashing, and uploading code updates during deployment. Here comes question number 249. Here's the scenario. An enterprise application running on Amazon EC2 instances backed by a MySQL database requires a robust disaster recovery architecture. Business continuity mandates a maximum recovery point objective, RPO, of 2 hours and a maximum recovery time objective, RTO, of 10 minutes, including recovery from a complete outage of the primary AWS region. Which combination of deployment strategies will satisfy these requirements? Choose 2. Choose every option that satisfies the requirement. The choices are: Choice A. Deploy an Amazon Aurora single availability zone cluster across multiple AWS regions and rely on automated cluster recovery features during a regional outage. Choice B. Deploy an Amazon Aurora global database spanning 2 AWS regions, configure cross-region replication, and prepare runbooks to promote the secondary region and update application connection endpoints during an outage. Choice C. Deploy an Amazon Aurora cluster across multiple regions fronted by a network load balancer distributing database transactions globally. Choice D. Deploy the application stack across 2 AWS regions, Configure Amazon Route 53 failover routing pointing to application load balancers in each region, and integrate health checks with auto-scaling groups. Choice E. Deploy the application across 2 AWS regions managed by AWS Global Accelerator pointing to application load balancers in a single unified endpoint group with automated scaling. The required selections are Option B. Deploy an Amazon Aurora global database spanning 2 AWS regions. Configure cross-region replication and prepare runbooks to promote the secondary region and update application connection endpoints during an outage. And Option D. Deploy the application stack across 2 AWS regions. Configure Amazon Route 53 failover routing pointing to application load balancers in each region and integrate health checks with auto-scaling groups. An Aurora global database provides managed cross-region replication and rapid promotion of a secondary region, comfortably supporting the stated RPO and enabling a low RTO with an established promotion runbook. Deploying the compute stack in both regions and using Route 53 failover routing with health checks provides a clear regional traffic failover path for the application tier. The remaining options can be eliminated because A. Aurora's single availability zone is not a multi-region database deployment and cannot provide the required regional database failover architecture. C. A network load balancer does not create a multi-region Aurora database or provide the required database replication and promotion capability. E. A single unified endpoint group does not by itself establish the explicit active-passive regional application failover architecture described in the requirement. Here's a useful exam tip. For multi-region disaster recovery, evaluate the data plane and application traffic plane separately. Use a managed cross-region database replication/failover mechanism and an independent regional traffic failover mechanism. Next up is question number 250. We're moving on to event-driven automation. Here's what is happening. A company provides employees with restricted AWS access, while DevOps engineers have permissions to assume an administrator role. For audit and compliance tracking, the security team requires near real-time notifications whenever any entity assumes the administrator role. How should a DevOps engineer accomplish this monitoring requirement? Option A. Configure AWS config to export log streams to an Amazon S3 bucket and use Amazon Athena queries triggered on an hourly schedule to alert the security team. Option B. Enable Amazon Guard Duty anomaly detection to monitor administrative role assumptions and dispatch automated findings via SNS. Option C. Create an Amazon Event Bridge rule filtering on AWS Management Console sign-in events to publish notifications to an Amazon SNS topic upon role assumption. Option D. Create an Amazon Event Bridge event rule using an AWS API call event pattern matching AWS CloudTrail events for role assumption to invoke an AWS Lambda function that publishes to an SNS topic. In this case, choose Option D. Create an Amazon Event Bridge event rule using an AWS API call event pattern matching AWS CloudTrail events for role assumption to invoke an AWS Lambda function that publishes to an SNS topic. Here's why. AWS CloudTrail records all API activity, including administrative role assumptions. By creating an Amazon Event Bridge event rule with an event pattern matching CloudTrail API calls for role assumption, DevOps engineers can automatically invoke an AWS Lambda function to parse the event and publish real-time notifications to an Amazon SNS topic. Here's why the alternatives are not suitable. A. AWS config and Athena queries introduce latency and are not near real-time event mechanisms. B. Guard Duty detects security threats and anomalies, but generic administrative role assumptions by authorized engineers do not automatically trigger Guard Duty findings. C. Management console sign-in events capture logins, not IAM role assumption actions executed via API or CLI. A helpful shortcut is this. For near real-time event-driven notifications of specific AWS API actions, such as role assumptions, combine CloudTrail, Event Bridge, API call event patterns, Lambda, and SNS. Here comes question number 251. Here's the scenario. A DevOps team manages numerous AWS accounts organized under AWS organizations. The team must ensure that all Amazon EC2 instances across all member accounts utilize strictly approved AMIs. Any deployment utilizing unapproved AMIs must be automatically remediated, and local account administrators must be prevented from bypassing or removing this restriction. Which solution satisfies these compliance and automation requirements? Here are the options. Choice A. Deploy an Amazon Event Bridge rule to all member accounts via Cloud Formation Stack sets to capture EC2 CloudTrail events and alert the DevOps team via an Amazon SNS subscription. Choice B. Use Cloud Formation Stack sets to deploy the approved AMIS by ID AWS Config Managed rule to all accounts configured with approved AMI parameters and attach automatic remediation using the AWS Stop EC2 Instance Systems Manager Automation Runbook. Choice C. Deploy an AWS Lambda function across all accounts triggered by EventBridge and CloudTrail events to evaluate EC2 instances and publish compliance alerts to an SNS topic. Choice D. Enable AWS config across the organization. Deploy an organization-wide conformance pack utilizing the approved AMIS by ID managed rule and configure automated remediation using the AWS Stop EC2 Instance Systems Manager Runbook. Go with option D. Enable AWS config across the organization. Deploy an organization-wide conformance pack utilizing the approved AMIS by ID managed rule and configure automated remediation using the AWS Stop EC2 Instance Systems Manager Runbook. Let's look at the reasoning. AWS Config Organization Conformance Packs provide centralized deployment of compliance rules and remediation across organization accounts. The approved AMIS by ID managed rule evaluates EC2 instances against the approved AMI list, and Systems Manager automation can stop non-compliant instances. Organization-level deployment provides stronger centralized governance than account-by-account custom controls. Let's quickly check the incorrect choices. A. Notifications detect activity, but do not continuously evaluate AMI compliance or automatically remediate non-compliant instances. B. Stack sets can distribute config resources, but an organization conformance pack is the purpose-built, centralized mechanism for organization-wide config rules and remediation. C. A custom Lambda solution adds code and operational overhead and, as described, only alerts rather than enforcing automatic remediation. The main takeaway is for centralized multi-account compliance. Prefer organization-level AWS config capabilities such as conformance packs when they can deploy both managed rules and remediation actions. Next up is question number 252. Next, let's move into Systems Manager. A DevOps engineer needs to ensure that corporate antivirus software is installed and running on all Amazon EC2 instances running Amazon Linux across an AWS account. The solution must automatically discover all managed instances and enforce installation using an AWS Systems Manager document if the software is absent. Which implementation method meets these requirements with the least operational overhead? Option A. Create an association and Systems Manager State Manager targeting all managed nodes, specifying the installation document and software package parameters. Option B. Configure AWS config resource recording across the account. Write a custom config rule to check software presence, and attach an automatic remediation action executing the Systems Manager document. Option C. Enable Amazon EC2 vulnerability scanning in Amazon Inspector and associate findings with a Systems Manager automation document for remediation. Option D. Create an EventBridge rule capturing EC2 run instances API calls, collect instance inventory via Systems Manager inventory, and trigger document execution based on inventory gaps. The answer here is option A. Create an association and Systems Manager State Manager targeting all managed nodes, specifying the installation document and software package parameters. This is the best choice because Systems Manager State Manager automates the process of maintaining consistent desired state across EC2 instances. Creating an association targeting all managed nodes with a Systems Manager document automatically detects missing software and installs it without requiring complex custom scripting. Now let's rule out the other options. B. AWS config custom rules and automatic remediation can work, but config evaluation intervals introduce delays compared to native state manager associations. C. Amazon Inspector focuses on vulnerability scanning rather than enforcing software installation compliance. D. Event bridge and inventory collection workflows introduce unnecessary architectural complexity compared to native state manager associations. Keep this point in mind for the exam. To enforce software installation and desired state configuration across an EC2 fleet, use systems manager state manager associations. Next, question number 253. Scenario. An enterprise manages hundreds of AWS accounts using AWS organizations. A dedicated IAM team requires administrative capabilities over the organization instance of AWS IAM Identity Center. The team must be able to manage users, permission sets, and assignments across existing and future member accounts while minimizing the need for administrative access to the organization's management account. Which combination of steps will meet these requirements? Choose 3. More than one answer may be correct. Options. Option A. Create a dedicated AWS account for the IAM team. Enable an account instance of IAM Identity Center in that account and register that account instance as the organization delegated administrator. Option B. Enable an organization instance of IAM Identity Center from the AWS organization's management account, then register the dedicated IAM team member account as the delegated administrator. Option C. Create the IAM team group and assign a permission set containing the AWS SSO Directory Administrator Managed policy, which only provides directory administration. Option D. Create the IAM team group and assign a permission set containing the AWS SSO Member Account Administrator Managed policy, so the administrators can manage users, permission sets, and assignments for member accounts. Option E. Assign the IAM team administrative permission set to the organization's management account and grant the group access to that account. Option F. Assign the IAM team administrative permission set to the dedicated delegated administrator account and grant the IAM team group access to that account. The correct answers are Option B. Enable an organization instance of IAM Identity Center from the AWS organization's management account, then register the dedicated IAM team member account as the delegated administrator. Option D. Create the IAM team group and assign a permission set containing the AWS SSO Member Account Administrator Managed policy, so the administrators can manage users, permission sets, and assignments for member accounts. And Option F. Assign the IAM team administrative permission set to the dedicated delegated administrator account and grant the IAM team group access to that account. The main reason is an IAM Identity Center organization instance is created in and remains associated with the organization's management account, but administration can be delegated to one member account. AWS SSO Member Account Administrator provides the IAM Identity Center administrative capabilities needed to manage users, permission sets, and assignments across member accounts. Granting the team access to the delegated administrator account allows those duties to be performed without routine access to the management account. The other choices do not work because A. An account instance in a member account is for that account and cannot replace the organization instance used for multi-account assignments across AWS organizations. C. AWS SSO Directory Administrator is focused on directory administration and does not provide the full permission set and account assignment administration required here. E. Granting the team the administrative permission set in the organization's management account creates the unnecessary management account access that delegated administration is intended to avoid. For organization-wide IAM Identity Center, keep the organization instance in the management account, but delegate day-to-day administration to a member account. Delegated administrators cannot manage permission sets provisioned to the management account. Question number 254. This is a harder question, so check every requirement carefully. Here's what is happening. A video streaming platform running on Amazon EKS scales to thousands of nodes during peak hours. Users have reported unauthorized account logins and sudden session terminations. The company requires enhanced security monitoring for malicious behavior associated with the EKS workload and a unified investigation view that correlates resource behavior, API activity, identity activity, findings, and network traffic across the AWS environment, while minimizing log management overhead. Which comprehensive solution satisfies these security monitoring requirements? Review the options. Option A. Enable Amazon GuardDuty EKS audit log monitoring and AWS CloudTrail logging. Store the logs in Amazon S3, query them with Amazon Athena, and visualize the results in Amazon QuickSight. Option B. Enable Amazon GuardDuty EKS audit log monitoring and Amazon Detective, and enable the EKS audit logs source package in Detective for investigation. Option C. Enable Amazon CloudWatch Container Insights and AWS CloudTrail logging. Export logs to Amazon S3 and build Athena and Amazon QuickSight dashboards. Option D. Enable Amazon GuardDuty EKS audit log monitoring, Amazon CloudWatch Container Insights, Amazon VPC flow logs, and AWS CloudTrail logging, and investigate each source separately. The best choice is option B. Enable Amazon GuardDuty EKS audit log monitoring and Amazon Detective, and enable the EKS audit logs source package in Detective for investigation. This works because Amazon GuardDuty can analyze EKS audit activity for threats, and Amazon Detective provides a behavior graph for investigation. Detective natively ingests and correlates core CloudTrail, VPC flow log, and GuardDuty finding data without requiring the customer to build and manage a separate log lake for those sources. Enabling the EKS audit logs source package adds detailed Kubernetes activity and EKS entities to the investigation graph. This can build a custom analytics solution, but it requires explicit collection, storage, querying, and dashboard management instead of using Detective's correlated investigation graph. C. Container Insights is primarily observability telemetry and, without GuardDuty and Detective, does not provide the requested threat-oriented, unified security investigation capability. D. Collecting the individual sources is useful, but investigating them separately does not provide the requested unified correlated view and creates more log management overhead than Detective. Exam tip. Use GuardDuty for managed threat detection and Detective for correlated investigation. Detective can ingest core CloudTrail, VPC flow, and GuardDuty data and can add EKS audit logs as an optional source package. Now for question number 255. Consider this situation. An application hosted on an Amazon EKS cluster running on Amazon EC2 instances scales automatically based on CPU utilization. Under heavy production loads, the application encounters severe memory exhaustion errors without scaling out sufficiently. The engineering team needs a current, AWS-managed approach to collect, aggregate, and analyze EKS node memory utilization in CloudWatch over time. Which combination of steps will satisfy these requirements? Choose 3. Identify all valid responses. The choices are: Choice A. Create an IAM role with the CloudWatch Agent Server Policy Managed Policy and associate it with the CloudWatch Agent Service account by using Amazon EKS Pod Identity. Choice B. Attach CloudWatch Agent Server Policy to the Kubernetes service account used by the application pods so the application containers can publish node-level memory metrics. Choice C. Install or update the Amazon CloudWatch Observability EKS add-on and enable OTel Container Insights in the add-on configuration. Choice D. Deploy only in AWS distro for OpenTelemetry tracing collector and rely on tracing data instead of enabling Container Insights metrics collection. Choice E. Analyze a predefined EC2 memory utilization metric in the AWS/EC2 namespace because Amazon EC2 publishes memory utilization by default. Choice F. Analyze the node_memory_utilization metric in the Container Insights namespace by cluster name to evaluate cluster node memory pressure over time. The answers that work here are option A. Create an IAM role with the CloudWatch Agent Server Policy Managed Policy and associate it with the CloudWatch Agent Service account by using Amazon EKS Pod Identity. Option C. Install or update the Amazon CloudWatch Observability EKS add-on and enable OTel Container Insights in the add-on configuration. And option F. Analyze the node_memory_utilization metric in the Container Insights namespace by cluster name to evaluate cluster node memory pressure over time. The current OTel Container Insights setup for EKS uses the Amazon CloudWatch Observability add-on. The CloudWatch Agent Service account receives a role through EKS Pod Identity with CloudWatch Agent Server Policy, and the add-on is configured with OTel Container Insights enabled. Container Insights then publishes node_memory_utilization, which can be analyzed by cluster name for cluster-level node memory pressure. The remaining options can be eliminated because B. The permissions belong on the CloudWatch Agent Service account used by the Observability add-on, not on each application workload service account. D. Tracing alone does not provide the required Container Insights memory utilization metrics. E. Amazon EC2 does not publish a native EC2 memory utilization metric by default. Memory metrics require an agent or another telemetry collection mechanism. Here's a useful exam tip. For current EKS container insights, use the Amazon CloudWatch Observability add-on with OTel Container Insights enabled and grant its CloudWatch agent service account the required IAM permissions through pod identity. Question number 256. Let's go. Scenario. An application uses a fleet of Amazon EC2 on-demand instances in an auto-scaling group behind an application load balancer to process critical, non-interruptible data. The application also processes non-critical memory-intensive workloads that can withstand interruption. Critical workloads require rapid scale-out during real-time traffic spikes, whereas non-critical workloads must optimize cost and scale according to memory utilization. Which combination of steps will implement these distinct scaling strategies? Choose 2. Select all answers that apply. Option A. For the critical workload auto-scaling group, configure a warm pool with instances in the stopped state, set a warm pool size, and update the launch template to use spot instances. Option B. For the critical workload auto-scaling group, configure a warm pool with instances in the stopped state, define the warm pool size, and create a new launch template version with detailed monitoring enabled using on-demand instances. Option C. For the critical workload auto-scaling group, configure only a lifecycle hook to validate bootstrap completion without creating pre-initialized capacity. Option D. For the non-critical workload, create a second auto-scaling group using spot instances, publish memory utilization as a custom CloudWatch metric by using an agent, configure target tracking with that custom metric, and attach the group to the appropriate ALB target group. E. For the non-critical workload, create a second auto-scaling group using spot instances and select a predefined EC2 auto-scaling memory utilization metric for target tracking. You should choose option B. For the critical workload auto-scaling group, configure a warm pool with instances in the stopped state, define the warm pool size, and create a new launch template version with detailed monitoring enabled using on-demand instances, and option D. For the non-critical workload, create a second auto-scaling group using spot instances, publish memory utilization as a custom CloudWatch metric by using an agent, configure target tracking with that custom metric, and attach the group to the appropriate ALB target group. Here's why. A warm pool of stopped on-demand instances retains pre-initialized capacity for the critical workload and reduces scale-out latency without introducing spot interruption risk. For the non-critical workload, spot instances reduce cost, while memory utilization must be published to CloudWatch and used as a customized metric for target tracking because EC2 auto-scaling does not provide a predefined memory utilization target tracking metric. Here's why the alternatives are not suitable. A. Spot instances can be interrupted and therefore do not satisfy the non-interruptible requirement for the critical workload. C. A lifecycle hook can control readiness transitions, but it does not provide pre-initialized capacity and therefore does not reduce launch latency as effectively as a warm pool. E. EC2 auto-scaling predefined target tracking metrics include CPU, network, and ALB request count, but not memory utilization. A helpful shortcut is this. Use warm pools when initialization time is the scaling bottleneck, and use customized CloudWatch metrics for target tracking when the required utilization signal is not one of EC2 auto-scaling's predefined metrics. Now for question number 257. Next, let's move into disaster recovery. A company is migrating mixed Windows and Linux applications to AWS, utilizing automation to provision EC2 instances mirroring on-premises configurations. The applications require shared storage accessible via SMB for Windows instances and NFS for Linux instances. Additionally, the company is establishing a pilot-light disaster recovery environment in a secondary AWS region and requires automated storage replication to the disaster recovery region. Which storage solution satisfies all SMB, NFS, and cross-region replication requirements? Choice A. Use Amazon S3 for application storage with cross-region replication configured between primary and disaster recovery region buckets. Choice B. Use Amazon EBS for application storage with AWS backup plans creating volume snapshots and replicating them to the disaster recovery region. Choice C. Use AWS Storage Gateway Volume Gateway configured with cross-region replication between the primary and disaster recovery regions. Choice D. Use Amazon FSx for NetApp ONTAP for application storage, Deploy an FSX for ONTAP file system in the disaster recovery region and configure NetApp SnapMirror replication. The right response is option D. Use Amazon FSX for NetApp ONTAP for application storage. Deploy an FSX for ONTAP file system in the disaster recovery region and configure NetApp SnapMirror replication. Let's look at the reasoning. Amazon FSX for NetApp ONTAP natively supports both SMB protocols for Windows and NFS protocols for Linux, making it the ideal shared storage solution for mixed OS environments. Furthermore, it integrates with NetApp SnapMirror to provide efficient, high-performance cross-region storage replication for pilot-light, disaster recovery environments. Let's quickly check the incorrect choices. A. Amazon S3 supports object storage, but does not natively provide POSIX file system NFS or SMB interfaces required for traditional Windows and Linux application storage. B. EBS volumes are block storage attached to individual EC2 instances and cannot be directly shared across multiple instances via SMB/NFS simultaneously. C. Storage Gateway Volume Gateway provides cached or stored volumes, but FSX for NetApp ONTAP provides fully managed high-performance, shared file storage with native SnapMirror replication. The main takeaway is when migrating mixed Windows and Linux applications requiring shared SMB/NFS storage with multi-region replication, use Amazon FSX for NetApp ONTAP with SnapMirror. Question number 258. Here's what is happening. A development team consumes open-source packages through AWS code artifact repositories configured with public upstream repositories. Following the discovery of a critical vulnerability in a widely used dependency package version, the security team develops a secure, patched version of the package. The company must immediately prevent developers from downloading the vulnerable version while enabling the security team to publish the patched version. Which combination of actions will meet these requirements? Choose 2. Select all answers that apply. Here are the options. Option A. Update the status of the vulnerable code artifact package version to unlisted. Option B. Update the status of the vulnerable code artifact package version to deleted. Option C. Update the status of the vulnerable code artifact package version to archived. Option D. Update the code artifact package origin control settings to allow direct publishing and block upstream package ingestion. Option E. Update the code artifact package origin control settings to block direct publishing and allow upstream operations. The answers that work here are Option C. Update the status of the vulnerable code artifact package version to archived, and Option D. Update the code artifact package origin control settings to allow direct publishing and block upstream package ingestion. This is the best choice because archived package versions cannot be downloaded from code artifact, so archiving immediately blocks consumption of the vulnerable version while preserving it in the repository. Setting package origin controls to publish, allow, and upstream. Block allows the security team to directly publish its patched version while preventing the repository from ingesting competing versions from upstream public repositories. Now let's rule out the other options. A. An unlisted version is hidden from normal version listings, but its assets remain downloadable, including when explicitly referenced or present in a lock file. B. Deleted is not a target status that can be selected with Update Package Version status. Deleting a version is a separate operation and is not the controlled status transition described here. E. Blocking direct publishing would prevent the security team from publishing the patched package version. Keep this point in mind for the exam. In Code Artifact, unlisted hides a version from normal listings, but still permits downloads. Archived blocks downloads. Use package origin controls to allow trusted direct publishing while blocking unwanted upstream ingestion. Here comes question number 259. Here's the scenario. An application running on Amazon Linux EC2 instances uses AWS Code Deploy for deployments. The repository structure includes an appspec.yml file, a config/config.txt file, and application source files under application/web. The appspec.yml file section contains instructions to copy config/config.txt to /usr/local/src/config.txt and copy root source files / to /var/www/html. What will be the resulting deployment location for the config.txt file on the target instance? The choices are Option A. The config.txt file will be deployed exclusively to /var/. usr/www/html/config/config.txt. Option B. The config.txt file will be deployed to /usr/local/src/config.txt and also to /var/www/html/config/config.txt. Option C. The config.txt file will be deployed exclusively to /usr/local/src/config.txt. Option D. The config.txt file will be deployed to /usr/local/src/config.txt and to /var/www/html/application/web/config.txt. The answer here is option B. The config.txt file will be deployed to /usr/local/src/config.txt and also to /var/www/html/config/config.txt. The main reason is the code deploy app spec.yml file section processes mapping rules sequentially. The first mapping copies config/config.txt directly to /usr/local/src/config.txt. The second mapping copies the entire repository root, source/ to /var/www/html, which includes copying the config directory and its contents into /var/www/html/config/config.txt. The other choices do not work because A. Ignores the first explicit file mapping instruction that copies config.txt to /usr/local/src/config.txt. C. Ignores the second mapping rule that copies the root directory contents to /var/www/html. D. Incorrectly places config.txt under application/web inside the destination directory. Review code deploy app spec.yml file mapping entries carefully. Multiple rules can copy the same source file to different destination paths if source patterns overlap. Next up is question number 260. This question takes us into infrastructure as code. Consider this situation. An enterprise runs Windows and Linux EC2 application instances across multiple availability zones in an auto-scaling group. The company requires a high-performance, durable shared storage solution providing sub-millisecond latencies, supporting SMB protocol for Windows and NFS protocol for Linux, with concurrent read and write access from all instances. Which combination of steps will establish and mount this shared storage solution? Choose 3. Identify all valid responses. Review the options. Choice A. Create an Amazon EFS file system with mount targets across multiple availability zones. Choice B. Create an Amazon FSx for NetApp ONTAP multi-availability zone file system. Choice C. Create general-purpose SSD, GP3, Amazon EBS volumes attached across all instances for shared storage. Choice D. Update user data in each application launch template to mount the shared file system. Choice E. Execute an instance refresh on each auto-scaling group to apply the storage mount configuration. Choice F. Update running EC2 instances individually via remote shell scripts to mount the file system. You should choose option B. Create an Amazon FSx for NetApp ONTAP multi-availability zone file system. Option D. Update user data in each application launch template to mount the shared file system. And option E. Execute an instance refresh on each auto-scaling group to apply the storage mount configuration. This works because Amazon FSx for NetApp ONTAP provides durable, sub-millisecond shared storage supporting both SMB, Windows, and NFS, Linux, protocols across multiple availability zones. To ensure automatically scaled instances mount the storage, launch template user data must be updated, and an auto-scaling group instance refresh applies the updated template across the fleet. A. Amazon EFS supports NFS for Linux, but does not natively support SMB protocol for Windows instances. C. EBS volumes are block storage devices and cannot be natively shared across multiple EC2 instances in different availability zones with concurrent multi-instance read/write file locking. F. Manually updating running instances individually does not scale for auto-scaling groups. Launch templates and instance refreshes must be used. Exam tip. For shared storage supporting both SMB and Linux NFS with sub-millisecond latency across multiple availability zones, Use Amazon FSx for NetApp on tap, configured via launch templates and instance refreshes. You have completed set 14 of the DOP-C02, AWS Certified DevOps Engineer Professional Practice Question Series. How did you score? Share your result in the comments. Work through all the sets to build broader exam readiness and cover more practice questions. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Thank you for watching, and I will see you in another practice set.